Okay, so welcome back. So this is your example number 12. So just beginning of this lecture, let me tell you one thing, that for DC circuit we will are solving so many problems. So when we will go for single phase as well as 3-phase AC circuits, at that time this this theorem or laws all will remain same, but as AC circuits complex number will be involved. So at that time we cannot discuss so many examples because it is a time bound thing. So at that time number of example will be reduced, but things are same as your DC circuit. Only thing is that there will handle complex number, right. So come back to this example. For example, in this case we have to determine your determine R Thevenin, right, for this circuit. But to look at that circuit, there is no independent source in this circuit. That means from your inspection you can make it that R Thevenin actually is equal to 0, because there is no independent sorry not R Thevenin, sorry V Thevenin is equal to 0, right, not R Thevenin, V Thevenin is equal to 0, right. So now question is that V Thevenin is 0, but you can find out R Thevenin because dependent source is there. This is 2 Ix and this is Ix. So dependent source is there. So what you can do is, for example, you can connect your what you call a current source, your independent current source I0. You can take I0 any value, say 1 ampere, right, 1 ampere, and this voltage say it is V0. V0 means this is the voltage your V0, right, this is the voltage your V0, right, because this is a common node and this is your V0. So this voltage actually V0, therefore R Thevenin you will get V0 by I0. So to do this, so let us go to that your equivalent circuit. So it is V Thevenin is 0, and now here you have made I0, that back because your one current source we have put it, say I0 is equal to 1 ampere, say, right, and this V0 actually that is something like a nodal analysis, it is nodal analysis. So this is your, if you take this is your ground, say this is your ground, right, and this voltage is V0 means this voltage is V0, right, arrow means it is plus and this is means this is minus, right, and this one is a common node because no elements, electrical elements are connected here. Basically it's a this it's a basically, or what to call, there is a common node, right. Therefore let me clear it. Therefore what you can do is you apply KCL. For example, current flowing through this, say in this direction, it is V0 by 4, this is the current, right. Here this Ix is upward is okay, but this direction current is your V0. Let me clear it, I am making again. So this is your V0 by 4, and if you take this direction the current, it will be V0 by 2. That means Ix is taken upwards, that means Ix is equal to minus V0 by 2, right, and this is your common node, this is a basically same node, right. Therefore if you think that this is the node, then this 2 Ix current, this current is coming out from this node. This is the, I mean we are applying KCL here, that I am making it here, it is a common node, right. Another current V0 by 4, this is your V0 by 4, this is also leaving this terminal. Another current, say Ix, we will take this Ix, we know Ix is equal to minus V0 by 2. Another current Ix, it is entering into this node. So this is your Ix entering into, and this I0 current also entering here, right. So this current I0 is also entering into the node, right. So these two current, this I0 and Ix, these two are entering. So if I write here I0 plus Ix, these two currents are entering into the node is equal to this 2 Ix plus V0 by 4, these are leaving as per this Kirchhoff's your first law. So 2 Ix plus V0 by 4, but Ix is equal to minus V0 by 2. So if you put Ix is here minus V0 by 2, then you will get the value of V0. You can solve for V0. that what we have done next, right. So, let me clear it. So, whatever I said, so that is your I 0, what the way I wrote I 0 plus I x is equal to minus 2 I x is equal to V 0 per 4. There I wrote I 0 plus I x is equal to 2 I x plus V 0 per 4, V 0 by 4. So, I x is equal to minus V 0 by 2, I told you. If you substitute, you will get V 0 is equal to minus 4 I 0, right. So, that means I 0 is equal to, we have taken your what you call I 0 is equal to say 1 ampere, any value you can take, it does not matter, right. And directly you are get here, actually here we have got the relation V 0 is equal to minus 4 I 0. So, here no question of considering also I 0 is equal to 1 ampere, no need, right, because let me clear it, because R Thevenin is equal to V 0 by I 0, that is actually minus 4 ohm. I told you that when dependent sources are there in the circuit, there is a possibility that R Thevenin may become negative. So, it is minus 4 ohm, that means negative value of Thevenin resistance indicates that circuit of that one, that is circuit figure 28 is supplying power, right. So, if dependent sources are there in the circuit, right, there it was one your current dependent current source was there. If dependent current source is there, then there is a possibility that R Thevenin may become minus 4, that means circuit actually is supplying the power, this is the meaning, right. So, in this case we got this relationship V 0 is equal to minus 4 I 0. So, no need to set I 0 or I 0 value, because directly we are getting V 0 by I 0 ratio is minus 4 ohm. So, this is one example I gave for negative Thevenin resistance, right. Okay. So, next we move to the your what you call another one. So, using Thevenin's theorem, you determine voltage across load resistance R L of the circuit shown in figure 30, right. So, this is your, it is chapter 4.30 you are making. So, it is a figure 30, right. So, we have to find out using Thevenin's theorem that your current through load resistance R L is equal to 4 ohm. So, for Thevenin's theorem what we will do, first we will remove this load resistance, right, we will make an open circuit, right, that what we have done, right. So, first let me clear it. So, that means this one if you come, that you have to find out your V or what you call the V Thevenin is equal to, so R L is equal to 4 ohm is opened here, right, and your basically this one is equal to V 1 2. When we write 1 2, one terminal means it is plus and 2 means it is minus, right. So, V of V Thevenin, VOC, that is V open circuit voltage is equal to V Thevenin actually is equal to V 1 2, right. So, let me clear it. So, that means your this is actually plus. So, this is arrow will be there and this is your what you call VOC is equal to V Thevenin. So, this is open circuit. So, no current is flowing through this 4 ohm resistance, because this is open, and therefore, you apply your what you call that KVL in this mesh. So, if you apply KVL in this mesh, the current is I, already I have marked it, but I am just making it again, the current is I. So, therefore, you can make it, I am writing here for you, it is 12 I, then plus, now you know everything, plus 6, then plus 6 I, then minus 24 is equal to 0, right. That means, your 12 I plus 6 I, 18 I is equal to 18, 18 I is equal to 18, therefore, I is equal to 1 ampere, right. So, I is equal to 1 ampere. So, when you know the I is equal to 1 ampere, let me clear it, right. So, now you apply your what you call here that your KVL. In this case, there is no current flowing through this 4 ohm resistance is 0. Therefore, if you apply KVL moving like this, so I can write here plus 6, right, and I is equal to, we got 1 ampere, right. So, plus 6 into I minus V Thevenin is equal to 0, because it is encountering negative terminal first. Therefore, V Thevenin is equal to 6 plus 6 and I is equal to 1. So, that is your 12 volt. So, V Thevenin is equal to 12 volt. Here it is already solved here, everything is solved here. So, and V Thevenin is equal to 12 volt. So, let me clear it. So, if you come here, that V Thevenin here, the way I showed you, it has been computed as your 12 volt, right. This is your V Thevenin is equal to V O C is equal to V 12, same thing. Next is we have to compute R Thevenin. So, let me clear it. So, for R Thevenin, that voltage source is short circuited, right. So, if voltage source is short circuited for R Thevenin, that means here this source is short circuited, this is short circuited and this is short circuited. That means this 12 ohm and 6 ohm are in parallel, with that this 4 ohm is in series, that will be your R Thevenin. So, let me clear it. So, here this is your two sources shorted, 12 and 6 are your what you call are in parallel, that means your R Thevenin is equal to 12 into 6 by 12 plus 6, right, plus this 4 ohm with that in series. So, basically it will be your 12 into 6 72 by 18. So, 4 plus 4, that is your 8 ohm, right, that is your R Thevenin. So, here R Thevenin is 88 ohm, right. So, let me clear it. So, next is this, that means this is your V Thevenin, this is your V Thevenin, with that R Thevenin is there in series 8 ohm, and now you connect that RL is equal to 4 ohm resistance in terminal across terminal 1 and 2. So, if you do so, then current flowing through this you find out. So, total resistance here it is 8 ohm, here it is 4 ohm, 12 ohm. Therefore, I is equal to say V Thevenin by R Thevenin plus RL, right. So, V Thevenin is equal to 12 volt and R Thevenin is equal to 8 ohm and RL is equal to 4 ohm. So, that is actually 1 ampere, right, that is 1 ampere. So, that means your I is equal to 1 ampere. So, that you got through this, that means 1 ampere current is flowing through this load resistance RL. If you change the RL to 5 ohm, 6 ohm, does not matter, you will get, if RL is variable and if you change the RL to 6 ohm, 7 ohm, 8 ohm like this, you will get the current through RL, because rest of the circuit will remain same. So, V Thevenin and R Thevenin always fixed part of the circuit will remain same. This is the advantage of the Thevenin's theorem, right. So, let me clear it. Therefore, your VL is equal to your 4 and current flowing through this is 1 ampere. So, it is 4 into 1, that is your 4 volt, right. So, voltage across this load resistance is equal to 4 volt. So, let me clear it. So, that is why this is we have got that 4 volt, right. Here it is 4 volt, right, VL is equal to. So, next one, varieties of problem we have taken. Next one is, by using Thevenin's theorem, determine current flowing through 3 ohm resistor between point 1 and 2, right. So, this is the problem, that you have to find out the current flowing through this 3 ohm resistance, say in this direction 1 to 2. So, between point 1 and 2, the 3 ohm resistance is there. So, first is you have to open it and you have to find out your what you call V 12 is equal to V O C open circuit is equal to V Thevenin, same thing, right. So, that you have to first find it out. After that you apply your after that you have to find out also that your R Thevenin. Now, if you open this 3 ohm resistance, first you remove it. So, let me clear it. So, here if you look into that, if you have opened it, the circuit is like this, it is your VOC, right. This is 1 and 2, 1 is positive, 2 is negative, arbitrary we have taken. If you want, you can take 2 positive, 1 negative, it does not matter, arbitrary it has been taken, right. So, this voltage, actually this voltage your what you call the VOC, that arrow tip is plus and this is minus. Now, if you want to find out what is your VOC is equal to V Thevenin is equal to V 12. So, it is how we will find out that first this way we have taken I2, right. I2 is taken this way because it is open. So, this is a separate mesh, it is a separate mesh because this is open. So, no current is flowing here because this is open, right. So, let me clear it. So, this is open. So, current is flowing like this here the way I have taken I2, this is I2 and this is your I1, two independent mesh. So, in this case direction of I1 is like this and I2 your one current source 1 ampere is like this is I2, that means I2 is flowing also this way you have taken I2 is equal to 1 ampere. Therefore, directly you can write I2 is equal to 1 ampere, because only current source is there and current is in this mesh, right. So, in this case to get that your I1 you have to apply your what you call that KVL. So, 6 plus 12 18 ohm, right. So, 6 plus 12 into I1 is equal to 6, because this is 6 volt. So, I1 is equal to 1/3 ampere, right, is 6 by 18. So, 1/3 ampere. So, this I2 is equal to 1 ampere and I1 is equal to 1/3 ampere. So, now let me clear it. So, this is your I1 and this is your I2, whatever I have explained, and this is your VOC is equal to V Thevenin, right. So, now what you do to get that VOC, suppose I want to apply KVL like this, say clockwise your what you call that anti-clockwise direction, right. So, suppose I have written like this. So, it will be look into that, it will be 12 I1, because I1 is flowing like this 12 I1, then it will be minus 2 I2, because I2 is moving like this, but we are moving anti-clockwise. So, it is minus 2 I2, right, is equal to V Thevenin is equal to this. I am writing here for you. Say it is basically 12 I1 minus 2 I2, then encountering minus terminal first. So, minus VOC, VOC is V Thevenin is equal to 0. That means, VOC, say you write is equal to V Thevenin is equal to 12 I1 minus 2 I2. That is what I have written, VOC is equal to V Thevenin is equal to 12 I1 minus 2 I2, that is 12 into 3 minus 2, sorry 1 by 3 minus, that is 2 into 1 is equal to 2 volt. So, V Thevenin is equal to 2 volt, right. Next is, now let me clear it. Therefore, for your getting your R Thevenin, this there is a current source. So, current source here it is open, you have to turn off, and voltage source it is shorted, here it is shorted, right. So, finally, you have to from that you have to get your R Thevenin in between 1 and 2, terminal 1 and 2. So, let me clear it. So, in this case 6 ohm and 12 ohm they are in parallel, that means 6 into 12 divided by 6 plus 12, right. With that this 2 ohm is in series, so plus 2, right. So, that is equal to 4, this will be 4, this part will be 4 plus 2 is equal to 6 ohm. So, that is why your R Thevenin is equal to here it is 6 ohm. So, let me clear it. Therefore, your this is your V Thevenin we got 2 volt, R Thevenin we got 6 ohm, right. With that 1 and 2 that 3 ohm is this is connected and path circuit is closed. So, that means your I is equal to it is V Thevenin divided by your R Thevenin plus this 3 ohm resistance, right. So, that is your 2 divided by 6 plus 3, right, that is equal to 2 by 9 ampere. So, through 3 ohm resistance that 2 by 9 ampere current is flowing, that is what is been done here, right. So, this is your 2 by 9 ampere V Thevenin by R Thevenin plus 3. Now, take this, hope you are understanding this, right. Next, using Thevenin's theorem, determine current through 10 ohm resistance, right, to 10 ohm resistance of the circuit shown in figure 36. This is actually figure 36. Just hold on, let me move it up little bit. So, this is my your what you call, this is my figure 36, and 10 ohm means in this 10 ohm, right, 1 to 2, not this one, 1 to 2, right, this 10 ohm. You have to find out the current through this 10 ohm resistance, and this voltage is given 20 volt. Now, question is when it will be you have to find out, then this 10 ohm resistance, say this 10 ohm resistance, first you have to remove it, that means you have to make it open circuit to get the open circuit voltage, which is Thevenin voltage, and then you have to find out also that your R Thevenin resistance. So, first let me clear it. So, what you can do is that look, the 10 ohm resistance is open, this has been opened, right. So, this is your terminal 1 and this is terminal 2. So, VOC actually nothing but V Thevenin is equal to several times I am telling is equal to V12. Now, once you have done it, now if you look into that your what you call that circuit, you have to find out what is I1, what is I2. So, this as it is open, that 1 and 2 this 10 ohm resistance is open. So, this I1 current, this is 90 ohm and 10 ohm both are in series. So, here also that I1 current is flowing. Similarly, this is open. So, I2 is flowing, that means this branch also I2 current is flowing, right. Therefore, you have to find that this, and across this the voltage actually will be 20 volt or what you call is connected. So, if I read all the circuit, let me clear it. If I read all the circuit, say I mean just for your understanding. So, 90 ohm and 10 ohm these two are in series. So, basically it is 100 ohm, right, and similarly 55 and 5 ohm both are in series. So, it will be your 60 ohm, and with that this 20 volt plus minus is connected, this is 20 volt, right, and current through this it is I1 and current through this it is I2, right. Therefore, I1 is equal to your 20 volt divided by 100. So, it will become 1 by 5 ampere, right, that is here it is I1 is equal to your 1 by 5 ampere. Similarly, I2 is equal to your 20 volt, because it is parallel circuit, divided by your 60. So, that is 1 by 3 ampere, right. So, that is your 1 by 3 ampere. So, let me clear it. So, that means you got I1 is equal to 1 by 5 ampere and I2 is equal to, say I1 we got 1 by 5 ampere, right, and I2 you got 1 by 3 ampere, this we got. Now, what you do in this, here you apply here in your what you call KVL, this is your VOC means V Thevenin. So, if you apply your what you call that KVL, so here also this side also left hand side also you can apply, you will get the identical result, same result. If you make it, so we are moving like this. So, this I1 current is flowing here and here I2 is like this, right. So, it will be 10 I1, it is 10 I1 minus this 5 I2, because it is we are moving this way, but it is going this way. So, minus 5 I2 minus VOC, that is equal to 0. That means, your VOC is equal to V Thevenin, that is equal to your 10 I1 minus 5 I2. Now, put I1 value is equal to this much and I2 value is equal to this much, you will get V Thevenin voltage, right. So, let me clear it. So, with this you will get that VOC is equal to 1/3 volt, right. After putting those value, you will get V Thevenin is equal to VOC is equal to this 1/3 volt, 1 by 3 volt, right. Now, second thing is, now you have to get the R Thevenin also here, or in between terminal 1 and 2, what is the R Thevenin. So, for R Thevenin, this voltage source is shorted, that means these 2 point is shorted. If you draw the equivalent circuit diagram for this one, then I can make this is 1, right, and your first before making it, let it hold on, let it be there. So, what I can do is for getting this your this equivalent to this, these 2 point are your this point and this point is connected by a wire only. So, if I make it like this, so this is 90 ohm, make it 1, this is 10 ohm, right. That means, this point I connect like this and this is your 55 ohm and this is your 5 ohm, right. So, this is 1 and this point is 2, right. So, these 2 are sorted, So, if it is so, that means, as these 2 points are sorted. So, 9 and 10, I mean these 2 have clubbed together. 9 and 10 are in parallel and 55 and 5 are in parallel. So, if you do so, that means if we redraw this circuit again, then this will be terminal 1 and this will be your 90 ohm and this will be your 10 ohm. This is your common terminal and this will be your 55 ohm and this will be your 5 ohm and this is terminal 2, right. So, equivalent to this one 90 into 10 divided by 100, right. So, it will become, for this part it will become 9 ohm and this one you have to calculate 55 into 5 divided by 55 plus 5, right. So, it is 90 plus 10, so it is 100 and it is 55 plus 5 60. So, this calculation is there. So, that will give you your what you call that with this one and this one are in series. So, let me clear it. So, whatever we have done, this is sorted, I told you. After that, these two are shown 90 and 10 and 55 and 5 are in parallel. Then this is 9 ohm and equivalent to this it is coming 4.58. So, total is R Thevenin is equal to 13.58 ohm, right. And with this 10 ohm, your this 10 ohm now is connected here. 10 ohm is this is your V Thevenin 1/3 volt, R Thevenin is this one and 10 ohm is connected here with that. So, ultimately you will get V Thevenin by R Thevenin plus 10, right, is equal to 1/3 13.58 plus 10. So, this is actually 0.014 ampere. This is your I, right. So, this is easy to understand. So, next is you determine the current through 50 ohm resistor of the circuit shown in figure 40 using Thevenin's theorem. In this case, difference between the previous one and this one, that here data may be different, but structure of the circuit in difference, that one extra resistance is connected here, that is 10 ohm, right. Previous case there was no resistor here, but 10 ohm resistance is there and you have to find out that what is the current to the 50 ohm resistance. Say this terminal you mark at 1 and this terminal you mark at 2, right, and then you follow. And so, first is we have to open this resistance 50 ohm resistance. So, if you open it, your circuit will be like this, So, in this case this voltage, this is your VOC. Actually, every time I am telling VOC is equal to V Thevenin is equal to sometimes V12, same thing, right. So, in this case if you do this, look, as soon as you open this one, this 50 ohm resistance is open. Now, look at that, this 30 plus 60, these two are in series. So, 30 plus 60 for this circuit is equal to 90 ohm. This side also, this is 60, this is 30. So, 60 plus 30 is equal to 90 ohm, right. So, here it is in series 90 ohm and 90 ohm, and that means this is 90 ohm, this is also 90 ohm. That means, let me clear it, that means I1 actually is equal to I2 is equal to I by 2, because whatever current is entering at this point, it will half of the current of half of I will go here, half of I will go here. So, I1 is equal to I2 is equal to I, that means I is equal to 2 I1, right, is equal to 2 I2. So, right, this is the first thing. Now, you can easily solve your what you call for I2 and I1, because I1 is equal to I2 and I is, that means here if you apply KCL here, let me clear it. If you apply KCL here, your I is equal to I1 plus I2, right. That is equal to either 2 I1 or is equal to 2 I2. This is what has been written here. Now, you apply KVL to get your what you call I1 and I2, I1 I2 same. So, you apply KVL like this, So, if you make it like this, then what will happen, this 10 into I, because I is flowing, let me clear it. So, I is flowing through this is I. So, 10 into I, right, plus we are moving like this, plus your this I2 current is flowing through 60 and 30. So, 90 I2, right, then minus 5 is equal to 0 because this 5 volt, right, but but question is that 10 I is equal to I1 plus I2 plus 90 I2 is equal to 5, right, but I2 is equal to I1. If you put it here, then you will get I1 solution for I1 and I2, and that is actually done here, right. So, this is your what you call I2 is equal to I1, we have got your 1 by 22 ampere. So, once you get I is equal to I2 is equal to I1 is equal to, this is your 1 by 22 ampere. After that you apply KVL in that thing, right. Just let me go to that circuit. So, here you apply your KVL. You can apply KVL either like this is your VOC, this loop you can apply. So, it will be your 6, this I1 is current flowing there and this is your I2. So, if you write 60 I1, then your minus 30 I2 is equal to VOC, right. Put I1 I2, you get VOC is equal to your V Thevenin. So, that is what is written there, here, right. So, we got VOC is equal to 1.36 volt, right. This is V Thevenin, VOC is equal to, there should not be any confusion, that should be is equal to V Thevenin. Now, next is your equivalent R Thevenin. So, what you do that this will be shorted, look at that, this will be shorted, that means this 10 ohm resistance, suppose it is not there. So, that means this will come here, this 10 ohm will be there because it will be shorted, these 2 point is connected. So, nothing will be there. So, suppose I am making it for you, suppose it is not there. So, 10 ohm will be here, right. So, let me clear it. So, that is what we have done in that here, right. So, here we are getting your what you call that your this 30, 60 and 10 ohm, they are in, it is in delta, we have to convert it to star, right. Suppose this is your R1, this is your R2 and this 10 ohm is equal to R3. So, R1 plus R2 plus R3 is equal to 30 plus 60 plus 10, 30 plus 60 plus 10 is equal to 100 ohm, right. And then you can find out the this what is the value of this branch, this is the resistance. So, 30 into 60 900 by R1 plus R2 plus R3. So, it is 18 ohm, right. So, 30 into 60 divided by 118 ohm. Similarly, 30 into 10, right, this branch, that means this is 18 ohm, 30 into 10 divided by 100, that means this is 3 ohm, this is 3 ohm, and another one is 60 into 10, 600 by 100, that is your 6 ohm. So, 18 ohm and this 1 and 2 terminal is like this. This is 1, this is 2, right. That means, let me clear it, that means 3 ohm and 60 ohm, these two are in series, and 6 ohm and 30 ohm they are in series, and with that this combine is in parallel. That means, it is equivalent is 63, this is 63 ohm and this is 36, right, divided by 63 plus 36, whatever it comes with that 18 ohm is in series with that. So, that is equal to what, right. So, if you let me clear it, that is what we have made it, that 18 ohm and 60 and this parallel, these two are in parallel. So, equivalent was coming 22.91 along with 18 ohm is in series. So, total is 40.91 ohm. Now, R Thevenin is 40.91 and here it is 40.91 and V Thevenin in that. With that you connect now the 50 ohm resistance which was taken off, right. So, you will get the current, and that is the current flowing to 50 ohm resistance. So, let me clear it. So, right, with that you will get your I is equal to your 0. 0.01 ampere, right. So, it is easy, Thevenin's theorem, rather than solving full circuit, only obtain V Thevenin and R Thevenin and then connect that resistance across it, and you will get that current flowing through the resistance. So, through 50 ohm resistance. So, this is the current flowing. Thank you very much. We will be back again.